Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Today we will solve some questions on the continuity of the function. Let me just remind you of the continuity test. To use the continuity test, we have to apply three conditions. The first condition is the limit of the function should exist. The second condition is the value of the function should exist. The third condition is the limit of the function should be equivalent to the value of the function. If any of these three conditions is not met, then the function is not continuous. So let's start with this problem number 1. Consider the function f of x equals 3x squared plus 2 for x is greater than minus 1 and less than 1. F of x equals to 7 when x equals to 1. F of x equals to 6x minus 1 if x is greater than 1. This kind of function is called piecewise defined function. The domain of the function here is from minus 1 to 1. So we write domain equals to minus 1 to 1. So now let's start with the first part. Find the limit of f of x as x goes to 1. So to answer this question, first we need to find the left side limit, lim f of x as x goes to 1 from left side. Means we are talking about values of x that are less than 1. So here, this is for x greater than 1, and the first formula here is for x less than 1. So we have to use the first formula. So we have to use 3x squared plus 2, this is the function, as x goes to 1 from left side. And we will use the substitution method. So if x is replaced by 1, then this will give us 3 plus 2, that is 5. So the left side limit to x equals 1 equals to 5. Now the right side limit, lim f of x as x goes to 1 from right side, means we are talking about x greater than 1. So we have to use the last formula. So lim 6x minus 1 as x goes to 1 from right side. So we have to substitute x by 1, positive 1. So this will give us 6 minus 1, that is also 5. You can see here the left side limit is 5, the right side limit is 5. So the conclusion here is the limit of the function is also 5. So this is the limit of the function. Now, part B, we need to find the limit also as x goes to minus 1. So again, we have to find the left side limit, lim f of x as x goes to minus 1 from left side. Means the values of x are less than minus 1. But here the function is defined only in this domain from minus 1 to 1. So for values of x less than minus 1, the function is undefined. So the limit here does not exist, DNE. The right side limit will be lim f of x as x goes to minus 1 from right side. So we are talking about values of x greater than minus 1. So we have to use this relation because this is valid for x greater than minus 1. So we have to substitute in this relation. So lim 3x squared plus 2 as x goes to minus 1. And now you substitute x by minus 1. So this will give us 3 plus 2, that is 5. But here the left side limit does not exist, the right side limit exists equivalent to 5, so the limit of the function at this point does not exist because the two-sided limits are not equivalent. So we'll say does not exist. Okay, the end. Now the part C of the question discuss the continuity of the function f of x, including the one-sided continuity at x equals -1 and at x equals to 1. So let's start with the first point at x equals -1. Now we found in part B that the limit does not exist. So here from part B, lim f of x as x goes to -1 does not exist. Okay, but since -1 is an endpoint, then the limit does not exist. Let's see the value of the function f of -1. What is f of -1? See, the function is defined at x equals to -1, and we have to follow this formula because there is equal sign. This formula is applicable for x greater than or equivalent to -1. So we can use it to find the value of the function at x equals -1. So if we substitute x by -1, so here we have to substitute x by -1. So we will get 3 plus 2, that is 5. See, the function here is not continuous at x equals -1. Why? Because the limit does not exist, and we said if the limit of the function does not exist, then the function is discontinuous. However, there is one-sided continuity. Why? Because this -1 is the end point, the left end point. So there might be continuity at this end point. So what we will do is we will say f of x is not continuous at x equals -1. However, the value of the function is equivalent to the right side limit, because if you go back to part B here, see the right side limit here is equivalent to 5, which is equivalent to the value of the function. So this is equivalent to the right side limit. So it's equivalent to lim f of x as x goes to -1 from the right side, which means that the function, f of x is left side continuous. Left side continuous because this -1 is the left end of the domain. Okay, the left end of the domain is -1. So when we approach -1 from right, its value is the limit is 5, and the value of the function is 5 at x equals -1. So it's continuous from the right to the point of -1. We call this the function is continuous at the left end point. So we call it left side continuous. Okay, this is at x equals -1. Now at the second point, which is x equals 1, we have also to do the same test. We have to apply the same test. So at x equals 1 here, we have to find the limit. So from part A, what was the limit? From part A, the limit was 5. Okay, So from part A, lim f of x as x goes to 1 equals to 5. How about the value of the function at 1? Okay, let's go back to the function. At x equals 1, the value of the function is given as 7. So f of 1 is equivalent to 7. Which means that the limit is not equivalent to the function, to the value of the function, which means that f of x is not continuous, at x equals to 1. Let's see if there is one-sided continuity. Here we are talking about the left side and the right side. Both of them are 5, and the limit of the function exists, 5. So none of these two-sided limits is equivalent to the value of the function, so the function is not continuous at x equals to 1. Okay? So to summarize again, what we did in part C at point x equals minus 1, we found the limit, which is determined in part B, does not exist. We found the value of the function at x equals minus 1, we found it 5. So the function is not continuous. But we have to search for the one-sided continuity, because the value of the function is 5, which is equivalent to the right side limit. Here, the right side limit is 5. So since the right side limit is 5, and this is the end left of the domain, then we will say this is the left side continuity of the function. At x equals 1, the limit exists is equivalent to 5 as x approaches 1. The value of the function at x equals 1 is 7. So the limit does not equal to the value of the function, hence the function is not continuous at x equals to 1. Okay, so I hope you understood the solution of these kind of questions. Now for the rest of the questions here, we use the graphical method. So let's see this graph. So this is the graph of a function f of x. The function is not given to us, only the graph of the function is given to us. So we need to discuss the continuity of this function by referring to the graph, including the one-side continuity at the following points. At x equals 0, at x equals 1, and at x equals to 2. Okay, let's start with the first point at x equals 0. Again, we have to find the limit of the function at x equals 0. So the right limit is equivalent to 0, the left limit is equivalent to 0, then the limit of the function is 0. The value of the function f of 0 is also 0. Why? Because at x equals 0, there is no open circle. So the graph is continuous here, or the graph is not broken. So the value of the function is 0, the limit of the function is 0, so the value of the function is equivalent to the limit of the function, so the function is continuous at x equals 0. Now when we move to the other point at x equals 1, here if you find the left side limit, you will find that the left side limit is equivalent to 2 and the right side limit is equivalent to 1. As you approach x equals 1 from left side, you have to follow this graph. So to the left of 1, if we are getting closer to 1 from left side, the value of y is 2. So the left side limit is 2. And if we are getting closer to 1 from right side, we have to follow this line, because this is the part of the function for x greater than 1. The value of y is 1. So the two-sided limits here, they are not equivalent. So there is no limit for the function. The value of the function here is equivalent to y, 1. Why? Because when x equals 1, we have a closed circle at this point, which corresponds to y value of 1. Don't follow this circle because this is an open circle. So the value of the function when x equals 1 is 1. So f of 1 equals to 1. Here we have the value of function is equivalent to 1. We have no limit for the function, or the limit does not exist, so the function is not continuous at x equals 1. But can we talk about the one-side continuity here? No, because x equals 1 is not the end point of the domain. It's an interior point. We call it interior point. The endpoints of the domain are -1 and 3. The left end is -1, the right end is 3. These are the 2 points that can be discussed about the one-sided continuity. So at x equals 1, the function is not continuous. And you can see in the graph here, the graph is broken. Okay. Now at x equals 2, the second point, or the third point, at x equals 2, here the limit is equivalent to 1 because the left side limit is 1, the right side limit is 1. So the limit of the function at x as x goes to 2 is equivalent to 1. The value of the function is 2 because the closed circle here means when x equals 2, the value of the function is 2, not 1. There's an open circle here opposite to y equals 1. So the value of the function is 2, the limit of the function is 1, and these two numbers are not equivalent. So the function is not continuous at x equals 2. Here are the details. Okay? Now if we move to problem 3, yeah, we need to discuss the continuity at 0, 2, and 4. So we have to follow the same steps. The solution is provided here. It's very clear. We have to find the limit of the function at each point. We have to find the value of the function at each point, and we have to compare the two values. If they are equivalent, then the function is continuous. If they are not equivalent, then the function is not continuous. From the graph, I can say at x equals 2, the function is not continuous because the graph is broken. At x equals 4, also the graph is broken here, so it's not continuous. The limit does not equal the value of the function. At x equals 0 is continuous. Okay? So here we have one more graph. Okay? We can say here the limit of f of x as x goes to -4 from left side. Okay, it's 2. From right side is 2. Is f of x continuous at x equals -4? No. Why? Because there is no value of the function. This is an open circle. There is no closed circle, so the function is not defined at x equals -4. So the limit does not equal the function, so the function is not continuous. At x goes to 1 from left side, this is 1. From left side, the limit is 4. From right side, we have to follow this graph. It's -2. Is function continuous at x equals 1? No, because the two limits are not equivalent. So there's no limit for the function. The limit does not exist. Okay, and this is not an endpoint to talk about the one-sided continuity. At x equals 6, the right side limit here is 2. The left side limit is from minus side, from left side is 5. Okay, and the value of the function here is 2. So the limit exists, it's 5. As we approach 6 from right side, the value of y is 5. So the limit is 5, the value of the function is 2, and these are different values, so the function is discontinuous. Okay? The solution is provided here for all the questions. Question 4, 3, 2. Okay? And this is for the analytical method. Okay, let me just add one more point here at x equals 3. At x equals 3, you can see here, let me just add this at x equals 3. The limit here from left side, lim f of x from left side equals to 1. The limit from right side is undefined, does not exist. Why? Because the function is undefined. So this is the right endpoint. So the left side limit is 1, the right side limit does not exist. The value of the function f of 3 equals to 1 because there's closed circle here. So the limit does not exist, the whole limit, but the one-sided limit here, the left side limit is 1, and the value of the function is 1. So we will say f of x is continuous from right at x equals to 3. So yeah, so the function has one-sided continuity. So from the right end, it's continuous. Okay, that's all about these questions, and you may refer to these solutions, and we can discuss further during our class. Okay, I'll stop here, and bye-bye. Assalamu alaikum.